Hello everyone, this is Prem Kumar. In this video, we are going to talk about the class and class group in Pega. First, I will talk about the object-oriented programming. In object-oriented programming, usually we create objects. First, we define a Java class file that contains the attributes and methods. From there, we can also create objects using the Java class. Generally, it is easy to maintain and faster to execute. Third is, it helps to keep the Java code dry. It means don't repeat yourself. We already know this concept that you don't want to reinvent the wheel and build the same source code again and again in different places. Instead, you can keep the source code at a common reusable place and then it can be invoked at different places. That's what we call it as don't repeat yourself. And Pega, they do use these object-oriented programming concepts. Now let's look at some of the differences between the Pega concepts and the Java concept. First, I would like to start with classes and objects. Classes and objects are the main aspects of Java programming. What you see in the screen, I created a simple Java class of car and then I defined two attributes and one method. Now from the main method, I can create a new object. I call it as RD and then I uses the class of car. By this way, this object is created of class car and it can use all the attributes and the methods that are defined in the class. In Pega, we do use the exact similar concepts. We can create classes in Pega and then we can also create objects or instances that corresponds to the class. So under classes, we usually put all the attributes. It can be properties, it can be your source code. Everything will go under the class and then instances can be created out of this class. For example, for the claims request, you can create a class layer of claims request and then you can create objects or the work instances of claims request and all your source code will go under the class inheritance path. This is one concept that Pega uses. There is also one more concept that is called class inheritance. In Java, we can inherit attributes and methods from one class into the other. Again, what you see in the screen, I have defined two classes. One vehicle class, which will be a generic class, and then a second class, which is of car that extends this vehicle class. It means it can use all the attributes and the methods that are defined at the vehicle class can be used by the car class. Now, if I create an object of car, the same RD, then I can use the properties that is in the inheritance path. It means I can also use the properties from the car as well as from the vehicle. Similarly, in Pega, we can also use the direct inheritance and pattern inheritance to reuse the code or attributes from a different class layer. I will explain it shortly in this video. Now let's go to Designer Studio and check the class configuration. So here I have logged in into the Designer Studio and currently I am into the App Explorer. Now, if you open the definition of the class rule form, you can do it in multiple ways. You can also go from sysadmin and open the class, or you can also right click and then use the definition that will open up the class instance configuration. Here you see this class is already created when we created a new case type. Remember in the previous video, we created a new case type and from there we created this class of claims request and this work layer is created during the application creation. I would recommend you to follow this link and go to the video where I explained about the enterprise class structure. Now, if you come back to this class configuration, the first main thing is you have to define the class type. There are two options which you will find. It is of concrete and the other option will be abstract. Since this class layer is created during the claims request case creation wizard, Pega has defaulted the class type as concrete. Now let's talk about some of the differences between this concrete and the abstract class. We know there are three types of class layers. First is the work layer, which can hold all the work instances. And second is the data layer, which can correspond to data instance where the source can be the local storage, or we can also use this data layer to map the external data. And third is the INT layer, which can hold all the integration related rules. Now let's look at some of the main decision points when we choose concrete class or abstract class. The first main option is concrete classes can have instances, whereas abstract classes, they cannot have instances. So instances here, what I refer to, you can think it of like objects. For example, for claims request, we can have a lot of claims request cases can be created. So cases can be referred to instances And when you want to have a class for clients records, definitely it should be of concrete classes because it can have instances. Now if you go to integration classes, in integration classes we just play with the data. We don't want to persist the data which is already stored in the external system, right? So those classes can be abstract classes. So all the case or work related classes can always be default or should be mapped to the concrete class type. Whereas all the integration classes, mostly like 95%, you have to mark it as abstract classes because integrations, you don't want to have instances. Okay, now we know about work layer, we know about integration layer. What about the data layer? Data layer, it can be concrete class, it can be abstract class. This is defined based on its usage or source. For example, if the data are stored in our system, then we can define it as a concrete class so that we can add a new entry or update existing entries. On the other hand, if the data is stored into some external system and we use some integration rules to get the data into our system, then we can have some abstract layer to just have the data mapped into our class. Again with an example, let's say if customer details are stored into our database, and then we can have a data layer that is mapped to the customer database, that can be concrete class because we persisted into our database as instances. And if the same customer data, if it is sourced from external system, then definitely we should use the integration classes to get the data, and then we can map the data into our data layer. So both this integration and data layer can be abstract class at that place. So now we know when to use concrete and abstract. The only main decision is if you want to have instances, go for concrete, otherwise always go for abstract. Because when you define a concrete class, Pega can also automatically create a table that is not really needed when you want to have it as an abstract class. So choose it wisely based on your requirement. So now we know all the work classes can be concrete classes, and for now it is not editable. So you see only concrete option, but when you create a new class, you get a drop down with concrete as well as abstract. So you can choose your option. The next is on settings block, where you can mention at which version this class rule gets created. This is mostly for the documentation purpose. You can specify the first version on which this class instance gets created. The next option is an interesting option where you can have a relation between class and class group. You have three configurations here. The first option is this class can be a class group. The second option, it does not belong to your class group. And the third option, it belongs to your class group. And by default, you see it belongs to your class group, and in the below field, you also see the class group name. First, let's open the class group name. Use this pointer to open the class group. So this opens up a new rule. You can also find all the class group instances by going to records, sysadmin and class group. If you click on it, you will find the list of class group instances that already exist. So why do we need a class group? As from the name itself, you can say that class group is a group of classes, and Pega by default, it did a very good design of specifying the work layer as the class group so that all the cases that inherit from the work layer, for example, the client's request is a class that belongs to this class group of work layer. In the future, we will be creating a new case called investigation, and that investigation also, it can belong to this work layer class group. By this way, this work class group can extend to different classes, or it can group all different classes under the class group. So why do we need this class group? The main use case is all the classes can be grouped and persisted under one dedicated table. So class group can be mapped to a database table, and all the classes that are part of the class group and all those instances can go under one table. So that is why you see the keys and logs defined into the class group rule form. In the class group rule form, you define the key for this class group so that all the instances will have the same key that extends or that belongs to this class group. Similarly, for logs, you can also define logs for your class group so that it can be applied to all the grouped classes. You can enable allow locking here. So these are the two main configurations in the class group. And if you go to the class rule form again, you see it belongs to your class group. The next option is a class group. When you choose is a class group and then do a save, what Pega does is it automatically creates a new class group instance. If you click and open now, it will create a new class group instance of the same name of the class because we defined this class as a class group, right? If you look at the third option, does not belong to your class group, and then just do a save, you get the error saying that work classes can be a class group or it can belong to your class group. It can never be does not belong to your class group. But data instances, it can be does not belong to your class group. Usually for all the data instances, you can just go ahead with does not belongs to class group and have a dedicated table. But for the work instances, you can say it belongs to your class group so that all the work instances can go under one table. But there will be some situation where you want to mark it as is a class group so that you get dedicated table for each of the case instances. There may be scenarios where you will have millions of cases for one particular class and you don't want to put that class under this class group layer because the table can explode. So in that case, you can mark that class as a is a class group so that it gets a dedicated table, and all of the remaining classes still it can belongs to the work layer class group. At the end of this video, I'm going to show you how to create a new work table, and I will also show you how your new class instances can go into the dedicated table instead of the class group table. Now let's get back here and change it to belongs to your class group and then just define it as work layer and then do a save. We just reverted back the changes. The third main option is class inheritance. During the introduction of this video, I told you Pega can use direct inheritance and pattern inheritance. First, let's briefly talk about this inheritance. So what you see in the screen is how Java can do the inheritance between classes. So car inherits from the vehicle class, right? Similarly, if you want to implement this same inheritance in Pega we can create a class of car, then we can also create a class of vehicle, and car can direct inheritance from the vehicle so that it can reuse all the attributes from the vehicle class. So under vehicle class, you can define properties, you can define activities, everything, and car can use the rules from the vehicle class because it is direct inherited. But Pega also has another inheritance, we call it as pattern inheritance. Do you remember about the situation layer cake where Pega's class can be formed using the organizational division or the application layers? What you see in the screen is how we can define the class layer for vehicle and car. If you look at the car class, you see it extends by alive-data-car. So this is what we call pattern inheritance. So alive data car can reuse the rule from alive, which is the organizational layer, or it can also reuse the code from alive-data, which is the organizational data layer. So you see there are two inheritance paths. One pattern inheritance path which follows the class path, and direct inheritance path where you can specify any direct class to which it can inherit from. Now if you come to Designer Studio, there you see under class inheritance there are two main configurations. One, you can specify the direct inheritance or the parent class. As we saw in the example, car class can direct inherit from vehicle class. Here by default, Pega has specified only the work layer as the direct layer. But in real time, if you use some kind of solution frameworks or if you build your own custom framework layer, then from the implementation class layer, you can direct inherit from the framework layer. In my scenario, I don't use any framework layer. So by default, Pega has assigned the class group as my direct inheritance layer. And pattern inheritance, we don't want to specify, right? Because if you see the class name, pattern inheritance is already in the class name. As you see, claims request, it can reuse from work layer, it can reuse from the application layer, and it can also reuse from the organizational layer. Now, which inheritance gets priority? Again, that is also can be configured into the class layer. As you see in the checkbox, when you say find by name first of pattern, name here refers to pattern inheritance. So pattern inheritance gets the first priority. This is by default enabled. So if you disable this option, Pega will not use the pattern inheritance. It will directly go to the direct inheritance path. Ideally, mostly 99% you will be using the pattern inheritance as the first priority. So you have to enable this checkbox in the class rule. Okay, now let's look at the inheritance of the claims request class. So if you go to the App Explorer and then right click on the claims request to check on the inheritance. This will open up a pop-up. There you can see the inheritance of this class. Here you can find a clear picture of different inheritance types. I will walk you through the inheritance layer. The first is on claims request. As you see, both direct and pattern inheritance to the work layer, because we know in the class layer we configured the direct inheritance also to the work layer, and pattern by default it is always work layer. So it comes here, and from here again it pattern inheritance to the application layer, and again a pattern inheritance to the organizational layer. Now all my pattern inheritance, the path is over. Now it goes to direct inheritance. But you see the direct inheritance, it refers to work-cover. we never specified work-cover, right? So how does this comes into picture? To know that, you go to the class rule form, and from there you click on the direct inheritance class. This is the work layer, and if you scroll down, you see this layer get direct inheritance from work-cover layer. So that is how the layers are formed. It keeps on coming till the other base class. If you again check the inheritance, it will see at the end it comes to the other base class. Again, work cover direct as well as pattern inherits to the work, and from work it direct inherits to other base class. To know that, just click here. It will also open the class layer. So if I click work layer, and from here, if you see the direct inheritance, you see other base class. So other base class is the very base layer which can be reused by work layer, data layer, and int layer. So this is the power of Pega. You can use the situation layer cake, and you can place your source code strategically at the right layer, and then the rule execution will use this inheritance path and pick the right rule for execute. I hope now you are a bit clear with the inheritance. Let's go to the test connection button. If you click on this test connection, you will see to which table it gets mapped to. We already saw in one of our previous video how a class can get mapped to the DB table via the database table instance. You can also find it from records, and then if you go to sysadmin and database table, and there you will see alive claims app work. If you click this, you will find the right DB table to which it gets mapped to. This is a database table instance which I am going to explain it in a separate video, but for now just understand that a class gets mapped to the DB table via database table instance in Pega. Okay, now let's move to the next tab. In the external mapping tab, you can map the properties to the column. Don't worry that you have to map every attribute to the column. Pega by default, it manages that. It will find the property name, and if there is a column of the same name, then it does the automatic mapping. But there may be situation where you want to map a different property into a different table column, then you can use this external table mapping so that Pega knows to which column this property should get mapped to. For example, let's say py label property. This py label property is of name py label, and if I want to map it to label column, then you have to specify the external table mapping because the column name and property name are different. A small tip: when you want to expose any kind of aggregate properties, Pega will automatically update this external mapping, saying like a page property dot py label can be mapped to a dedicated column. Then you will find the external mapping of the class gets updated. The advanced tab is of less interesting, so I'm not going to explain about it. Okay, now we know enough of the class rule configuration, and remember that we can also find the class instances from the app explorer. If you click on here, since this is a concrete class, it can open up the class instances. Now if you go to alive, which is the organizational class layer, and click on the class, you will get an error saying that you cannot create instances for alive. So it's not going to list you any kind of instances because alive is of type abstract. That's why they cannot have instances. If your class is of concrete, you can very well go here and click on it to check the instances instead of going into the DB. Now a final step of this tutorial, I'm going to create a new class group and then map these class instances into a dedicated table. To do that, we already created a new class group instance. So all you have to do, just say is a class group and then do a save here. Now that we said it is a new class group of class clients records, now we have to create a DB table and do the mapping. So how to create a DB table? In this scenario, I'm going to share you a small trick. Since we are going to create a same work table that is already part of class group table. So what you can do is you can go to your Postgres admin console and go to your right work table, right click and then use the create script. It is going to give you the create script to create this table. Now all I have to do is I'm going to say clients records will be my new table that is going to hold all the clients records instances. Then I will use all these default columns as such. And finally, what I will do, I will just change my constraint. I want it to be work hyphen clients records, and table space is fine, and change the alter table. For now, I will also remove the indexes. I don't need at this moment, so I'll just remove it. So this will create a new table of name clients records. Let's execute it. So you see a new table or an alter table has been done. Now if you just do a refresh and go to your table, there you should find a new table. There you see we created a new table. So now the next thing is we have to do a class mapping, right? We defined this class belongs to a class group and this is the class group. So definitely we have to do a class mapping using the database table instance. So to create a database table instance, you can use the Create menu, go to sysadmin and then database table instance. Just specify the right class name. So clients records is going to be my class name, and then do a create and open. And from here you can select the database table. It's going to be Pega data, and you can just specify the table name. The table name is PC A Life Clients of Work Clients Records. Then just do a save here and then do a test connectivity. You see we have successfully connected. Now you should go back to the class and also do a save. So just go to this clients app records and then do a save. Now do a test connectivity from here. You also see this class is now mapped to the clients records, which is a dedicated table. And how we did that is we changed this configuration from belongs to a class group to is a class group, and then we had a dedicated table. And don't forget to provide the key and the class group name, the new class group name. So I'm going to say PYID will be my key, and just say the key caption can be ID, and logs, just enable the allow log and do a save. Now let's create a new clients records case. We want to verify that if the clients records case goes into the dedicated table. Use the create menu, new clients records, and then just do a submit. Now we see a new case C-3 got created. Now if you go to the new table and let's check the view data for this table, all rows, you should see one row here saying that C-3 is just got created now. So I will end this video here. Hope it is clear and informative. If you like this video, please do like and share it with your friends. And if you have some questions, please drop a comment at the below of this video and I will be there to answer for you. See you in the next video.